Hello, everyone. It's great to be here with all of you today. As Ishan said, I'm a grad student at MIT and a researcher with an independent research lab called Ink and Switch. And today I want to talk to you about personal software. It's been really neat seeing these awesome talks by Rupert and Mav talking about some of these ideas for how newer technologies like AI or local first software might feed into a more personal connection with our software. But today I want to start by going way, way back to where it all started. If you can believe it, actually 50 years ago now, with the birth of the personal computer. This is Alan Kay writing in 1972, and he envisioned the personal computer as this fundamentally new medium that would change the way that society worked, that people even thought about things in ways that no prior medium, the book or the newspaper, had ever done before. This is basically a picture of kids playing with iPads, right? Some combination of prediction and invention going on there. But what are those kids doing on those iPads? They're not like watching Netflix, right? That's not what the goal was. These kids, one thing he envisioned is maybe they're playing a video game, and then in the middle of the game, they decide, I have an idea for how the game could be different. So they pause the game and they tweak it, and they learn a little bit of something about game design and a little something about physics. That's the kind of vision that Alan had. There's this quote of his that I really love. We now want to edit our tools as we have previously edited our documents. We now want to edit our tools. And the thing that motivates a lot of my work that I would ask you is, have we done this? Like, when you use your computer every day and something bothers you in your tools, do you fix it? I don't know about you, but for me, the answer is often no, unfortunately. It feels like we have a long way to go towards this vision. And when we think about why, one of the reasons I think why is really nicely articulated by my friend, the researcher Jonathan Edwards, who says, we were promised these bicycles for the mind, right? These tools that would amplify our natural intelligence, let us think new thoughts. And what did we get instead? We got aircraft carriers. Okay, wait. What does that mean? Here's what I think he means by that. The bicycle, it's this very personal artifact, right? It's lightweight, it's yours, it's modifiable, it's human scale. The aircraft carrier, that's enterprise software. I won't, name any specific names, but it's made by someone else, right? It's this huge industrial artifact. You're not going to get on an aircraft carrier and start, painting the walls and stuff. It's just handed, down from some factory. And I'm not really saying that either of these is better than the other necessarily. I'm just pointing out this is a huge difference in how you think about tools. And what I think a lot about is how can we make computers more faithful to that vision of the bicycle for the mind. So today I want to, in this talk, address two questions. The first one is, how can we get back to that vision and use computers more as this personal dynamic medium? The second question is, we have AI in the air now. It's a trend. And there's a lot of ways we could use it. Some seem more thoughtful than others. And I want to ask, how can we fit in AI in support of this original vision of personal dynamic medium? And the main way I'm going to kind of walk through these questions with you is this deep dive case study on a computational medium that I helped design together with some collaborators called Potluck. And it's a kind of computational note-taking tool which blends text notes and computation and dynamic interfaces. And you can do all sorts of neat things. You can manage recipes and household chores and meetings. And we'll get to those demos in a second. I'm also going to share some new demos with you that we haven't really shared before that have just been brewing in the past few weeks. So that's where we're going. But first, I want to back up a bit and talk about some other inspirations in terms of what do I mean by personal dynamic medium? What can we have in our heads when we think about that? I think one great example is the humble spreadsheet. You might love it, you might hate it, maybe a little bit of both, but you've probably used it, right? And I think even though we take the spreadsheet for granted, it's really quite an unusual artifact in our computing ecosystem today. And the reason is, it's sort of like a document. You just type in it, put some numbers, right? But it's also kind of a computational artifact because when you write these formulas, you're actually doing computation. There's behavior. You're simulating something or analyzing something. And the neat thing is, when I send you a spreadsheet, it doesn't just have my analysis, you can also change it. So if you don't like the simulation that I did, or you want to tweak something, or add something, or change the formatting, that's in your control, right? And that's very, very different from if I send you a dashboard made in some dashboarding app where you only get the knobs that I gave you. You really have full control over this open-ended medium. Another example is this project called WebStraits by Clemens Kalakmos and collaborators. And in WebStraits, what you're seeing here is two people editing the same academic paper in different tools at the same time, across different kinds of devices, mixing pictures and text, even live editing the state of the UI live in the UI itself. It's this very dynamic, malleable feel. You edit your tools as you use them. Here's Dynamicland. This is a project by Brett Victor and collaborators. And the idea at Dynamicland is the computer is kind of imbuing the entire physical space with computation. So you can sit around a table and have a conversation about some data while analyzing it live, however feels right in the moment. This doesn't really look like using an app, right? It's a much more flexible medium for thinking together. Here's some work by my colleagues at Ink and Switch, thinking through what they call programmable ink. This is one project by Shimon Kaiski, James Lindenbaum, and Josh Horowitz, where they were trying to explore if you have inking on a tablet and you want to turn that from a mere simulation of paper into a rich computational medium, what does that look like? How does that feel? Maybe one example is you sketch out a UI quickly with pen, and then you make a little slider to adjust some parameters, and you can have this live computational element mixed into your sketch. Finally, I'll just show you one example that I worked on in the past, this system called Wildcard. And the vision here was, what if every single website that you go to on the internet was built with a spreadsheet, and you could open up the spreadsheet and edit it? So imagine if Hacker News had a spreadsheet that you could just open up and maybe sort by one of the columns, and when you sort the spreadsheet, the original page updates as well. And you can go much further with this, adding spreadsheet formulas that, here I'm getting the read time for each article, and eventually I'll end up making a little browser extension, essentially, where I show read times for each article in the original website. And so all of those inspirations, I hope, give you kind of a flavor for what I mean by this personal dynamic medium. It's a vision for software where you control how the tool works and you can edit it live as you use it. OK, and that brings us to Potluck, the main thing I want to talk to you about today. Potluck is a project that I worked on together with Max Schoening, Paul Shen, and Paul Sonnentag, again at Ink and Switch. And I want to start with kind of a motivating example for what we were trying to figure out with Potluck, which is, why is it so hard to use a computer to manage a recipe when you're cooking? That's the question I had, because I cook a lot. OK, so here's one option. I can just type my recipe into Apple Notes. Very, very simple, right? I can type anything I want, anywhere I want. This is a coffee recipe that I was using last summer, because I like coffee. And I find this really nice. It's just so straightforward. There's no hassle, no settings to tweak and so on. Notes are very flexible, but they aren't really computational. That's the drawback. When you think about it, using a Notes app is kind of like a simulated piece of paper, right? OK, so that's the Notes option. What else could you do? Have you ever used a recipe app? Probably some people here, right? Here's one recipe app called Paprika. It's really nice. And what I can do is I can put my recipe into the app. Oh boy, I got to get each of the bits of data into the right place. The ingredients have to be in the ingredients thing for it to work. I should probably put the notes in the notes thing. There's a little bit of fuss. OK, but once I'm there, it really has some neat computational features. So for example, I can automatically scale the quantities. I can double the recipe, triple it, whatever. I can set timers right in the recipe. These are amazing things. This is what computers are for, right? So this is great. The problem, though, is that we kind of have the opposite problem with the Notes app. So here we've gotten computation, but we've given up a lot. So I've now ceded control of this entire experience to the app developer, who basically decides, this is a recipe cooking app. Here's what it means to be a recipe app. Here's what recipes apps do and don't do. And I find this really annoying, because often there are little bits of functionality that I want to add to the app, but I can't. And then there are other things that I don't care about that are in there, right? There's like pantry management and meal prep, and I don't need that. I just want to store my recipes. We also have these rigid data schemas where you saw that I had to put my data in exactly the right shape for paprika. And that bothers me too. Okay, so now you see the problem, right? This is what we were aiming for in Potluck is, can we find some set of primitives where you get the best of both worlds, where you can start with just a normal text document and then gradually enrich it to have computational behavior just the way that you want it to. That's the goal. And we thought about it a lot and ended up coming up with a relatively simple model that can actually do a lot. The basic idea is you start with these extensible searches where you find structured data in the text that you care about and you kind of pull it out of the text. Then you bring it into this computational environment, which is sort of like a spreadsheet, where you can do live computations on that data that you extracted. And then the last step is we're going to close the loop by having dynamic annotations where those computational results show up back in the text. And by completing that loop, you start turning a text document into a user interface. All right, enough talking. Let's see an example. So here I have that coffee recipe from earlier. And this is just a note stock. I can just type into it. The base feeling is just like apple notes. But now let's say I want to build one of those paprika features myself. So as a simple starting example, I'm going to say, let's double all the quantities because I want to make 2 cups of coffee. How's that work? The starting point is that we're going to open up this little menu on the right, and it's the search panel. This is basically Command F. So for example, I could take any text that I see, like I could type in 11G, for example, and it's just going to find it in the document. And when I hit enter, we get a little list of the results. It's also live, so I can see there's our search result, and if I type 11G again, of course, we're going to get another search result, right? So far, pretty simple. Now, I don't really want to search for 11G, though. What I kind of want in this case is to search for any quantity in the recipe. Now, in this case, I've just written all of them as in grams, so I can just search for any number followed by grams. And in Potluck, we have a little tiny syntax to do that, generalize the search. Now it's searching for all numbers followed by G. And I can even do a little extra step here, which just pulls out that number bit and gives it its own column in our spreadsheet. OK, so now you've seen step 1 of the loop. We've pulled out the data. Now it's time to compute with it. The computational bit is sort of like a spreadsheet. So all we're going to do, we can just add another column to our table. And I'm going to do a very simple computation here, just amount times 2. There you go. We've doubled the quantities. I can give it a name. Now we're going to close the loop with dynamic annotations. I can just show these results in the document. So I could show them, for example, next to the text. You see they're kind of next to where they originally came from. You can show them inline above. In this case, I'm just going to replace entirely. That feels good. And this is all running live as I type. So if I type in another number followed by G with a quantity, you'll see it just instantly runs as I type. So just with that simple computation, what I've kind of done is I've created this live, reactive running thing that's always going to be running as I edit my document. All right, I guess one last little tweak I could make here is that we kind of lost the G, the grams unit, right? So it'd be nice to add that back. The trick here is that these computations, they're actually just tiny snippets of JavaScript. So I can use a tiny bit of JavaScript here, the string interpolation syntax, to add the G at the end again. And just like that, we've done ingredient doubling. So that was just a little example of now I can close up that search panel, and I have a live editing thing that's always going to double quantities that I enter into this doc. And I hope that illustrates, it was just a tiny example, but I hope it illustrates how simple that interaction model is. There's really not that much to it. The interesting thing is when you just take that little kernel of an idea and you start applying it in lots of different documents and domains, what we found is that you can do a surprising amount of stuff with it. So that's what I'm going to show you next. So here's one example, same document, but I've added a little something. Do you see it? I've added a slider, a GUI element in the doc. And what I can do is I can just drag that slider and scale my recipe with the slider. Feels a little nicer than typing, maybe. This is also implemented with the exact same mechanism. So if I actually look under the hood, all this is doing, we can open it up. And there's just a formula somewhere in a spreadsheet that outputs a slider as a little data value. And that's being pulled into the document, just like any annotation. There's a formula for sliders. Now, another thing we might want to do is sometimes use pre-existing searches that someone else already created. So for example, what I can do in this case is add a timer to my document, and I'm just going to search for a pre-existing thing, durations. There it is. I click on it. Someone else already made that. I can just pull it in, and now I have a timer that I can run inline in my document. I didn't have to make that from scratch, right? We have sharing of tools. And of course, this is reactive too. So every time I type into my doc, any duration, I get a live timer running. And as you'll see later, the reason that someone else made a timer wasn't necessarily related to cooking as a domain, right? Timers are useful for all sorts of things. There's these very generic tools that you can pull into your domain-specific documents. All right, let's look at a couple other docs now. Here's a plan for a meeting. If you've ever been in a meeting, you know sometimes they're not running exactly on schedule, right? And so you have to adjust on the fly. And this is a doc that makes it really easy to do that because you note the start time and then you write down the duration of each segment. And as you edit them, it shows you what time each segment is supposed to be happening at, live on the fly. And what I find neat about this is not some whole meeting management application, blah, 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 right? This is just a tiny little utility that you can use to do a very simple computational task that's still useful. Here's a little bit more sophisticated example where we have more tools going on. We have formatting for to-do lists. You know, I can mention my teammates, and we have formatting on that. We have timers running for our agenda. I made all this myself in the tool. Here's another fun example that I like. This is for household chores and tracking watering your plants. Again, the kind of thing where, yeah, you could download an app, but do you really need to? It's not a complicated thing. So the way this works is you just write down what are all your plants, how often do you need to water them, and when did you last water them. And if it's time to water, it'll turn red. And you'll also notice there's these little buttons on the side. And if you click it, it just sets the date to today. And I can still edit the date as text too. But you know, very simple little utility. Here's a cash register for a bake sale. Again, you don't need to install like Square or some POS thing to run your little school bake sale. Just set the price, give an emoji to each thing you're selling, and then put emojis in the sales section and count up how much each sale was. You get a little total at the bottom. Very simple stuff. Finally, one thing that we also explored is, what if you take that table view on the right and you actually put rich data views on top of it, showing the structured data you extracted? So on the left side here, we have a workout tracking doc. This is a real doc that I wrote originally on my iPhone. And I personally hate workout apps. They're just too much ceremony for me because I'm not really trying to keep exact track of everything. I just want a super light way to keep track of basically what I did. And so what's happening here is that I'm going to add a workout on the left side, and it'll just show up in the calendar on the right side, just so I can see a little bit of a calendar view of what's going on. I think it's going to show up on July 22nd. I'll say bench, boom, it shows up. Squat, great. And I can hover on the calendar and see the text that went into that part of the calendar, right? So that establishes kind of this sync between the two representations. And the general point you're getting here is that these are very simple little utilities that you can use in your personal life, and you don't really necessarily need the full-blown power of an app that someone made to do this stuff. You can do all of it in one shared computational medium. All right, hopefully that gives you a bit of flavor for what you can do with Potluck. Now I want to share just a few things that we found using this tool ourselves that we found interesting. The first one is, you may have noticed, tools can be reused across domains. This is a big difference from how apps often work. A timer, it can time a plank in a workout, it can time cookies in the oven. It's just a timer. It doesn't need to be tied to some specific domain, right? You can make a timer once, use it everywhere. A second important thing is that you can bring multiple tools into OneNote and use them together. So in the recipe, I had quantity scaling, timers, calendars, all in one note. I can pick and choose just the tools that I want and none of the tools I don't want. A third one, this one I found particularly interesting. We came up with this word of personal microsyntaxes to describe this phenomenon where we found that often when you write something into a text note, you've come up with some way that feels good to you to write down that information, right? It's just however fits your brain. And it's nice that you can teach Potluck to just recognize that way you were already typing it anyway, instead of having to learn some new way of typing stuff to fit the computer. And another thing we noticed is that once you have the recognizer loop running and recognizing on the fly, it kind of gives you a nice incentive to stick to that syntax and do your best to kind of arrange the information in a way that's always going to parse properly. All right, this is kind of the one drawback, though. We found that in practice, writing code is a bottleneck, kind of a bummer. And what I mean by that is, I showed you some very simple snippets of JavaScript in those little boxes. But in practice, as you start building more and more complicated stuff, the snippets kind of get larger and larger. And this is unfortunate for two reasons. The first one is that if you're a programmer like me, even someone who worked on the system itself, when I'm in the middle of doing my workout tracking and then I'm confronted with a change I want to make to a tool, it's sort of a mental shift to switch into programmer mode, and I have to get into this formal technical mindset just to make the tool do the thing that I want. And there's an even bigger problem, which is that if you don't know how to program and you don't know JavaScript, then you're really out of luck, right? You might need to find a friend or maybe muddle through the simple JavaScript you do know. It's really not great. And what I want to point out is that I think this problem is not unique to just Potluck. This is actually a problem in many computational media. So just as a simple example, take the spreadsheet that we talked about earlier. When your formula is a little bit of math, it seems so simple. And then maybe you've been there. It gets more and more complicated. Bob wrote a formula, then he left the company. And until, at some point you're left with this, right? This is a real formula I had to read at some point. And this is just tough. It's a real burden. You have to do a lot of thinking to sort of figure out what's going on. And even authoring something this complicated can get really gnarly. And this is where we come to the second half of my talk. That second question of how can large language models help? One of the things that large language models are capable of doing, at least to some degree, is taking vague ideas that people have and writing code for them. And so hopefully the opportunity is sort of obvious at this point. I think a really interesting idea to consider is, can we lean on LLMs to help end users write small little bits of code within the larger context of a powerful computational medium? And what I find interesting about this is that fundamentally the user's in control, they're writing personal software, they're deciding what to do, they're in a medium where they kind of have precision and control. And the large language model isn't really kind of automating the entire process they're trying to do, it's just filling in these little bits of code and helping them build their own tools. That's the vision. Okay, so we've been working on a few demos of how that might feel in Potluck. These are very early, but I just want to show them to you to kind of illustrate what I mean by this. Okay, we're back to where we were earlier with the coffee recipe. And earlier I said it was simple, but it did take a few minutes and it was kind of tedious to get those quantities doubled, right? So what if we could just have the AI do it for us? This time I'm just going to click in that search panel again, but this time I'm going to write natural language. So I'll just say double the quantities. Hit a button, and the AI is going to generate a spreadsheet that tries to do the thing that I asked. Okay, and in this case, it worked flawlessly. So we can see kind of the spreadsheet that it generated. We can see the live results of each computational step. We can even ask for an explanation for what's really going on here. So I can click that button, and an AI will tell me what it sees happening in each step of this computation. It extracts the amount in unit for each ingredient, computes the doubled value in doubled, finally doubled with label adds the unit, and displays the new quantity in line. Okay, that sounds sensible, right? And in fact, it's essentially doing the exact same thing we did earlier manually. But what I want to point out here is that it's not sort of this one monolithic step that you have no visibility into. It's broken down the problem into smaller steps, and you actually can just click into any of these formulas the way you were doing previously and look at what they're doing, right? In fact, you can even edit them directly. So what if you want to change from doubling to tripling? Just go edit the formula. You don't need AI for that. Just change ×2 to ×3, ×4, whatever you want. It's super fast, super predictable. A really important point here is that at this point, there's no AI happening anymore. The AI part's done. I could do the replace text thing I did earlier. This is just JavaScript code running at this point, so it's extremely fast. It's always going to do the same thing. It's never going to make a weird math mistake. And you can see what it's doing at every step. All right, let's see another example. So here what I'm going to do is try a conversion from grams to ounces. Maybe I only have an ounces scale. And this time it's not going to go quite so well the first time around. Okay, ooh, that's ugly. Okay, I guess it did a multiplication, and that seems right, but this number is terrible. Round it. So I can just go edit that natural language description right there and hit the button again. And what the AI is going to do now is it's going to try to make an edit to the existing sheet that updates in response to my new intent. And we can see, okay, it did the rounding. Seems like it worked. We now have these nice numbers in our text, right? But an important point here is that one of the values in the system is that as you do stuff with AI, the goal is that you become more and more self-sufficient. You learn stuff. It's funny, I made this demo recently, and it's been a while since I built the system, and I actually was thinking to myself, wait, how do you round in Potluck? I don't even know. And so what I was able to do is just go look at how the implementation worked that it came up with, right? Okay, so we still have the multiplication going on there. Oh, ounce rounded. Look at that. We have a round formula, super easy. And I guess the 2 is how you get the number of decimal places, right? And so the idea is that as a user, if you generate these things and poke into them and see how they work, next time I need to round something, maybe it'll just be faster to do it myself. I'm not really becoming more reliant. I'm almost becoming less reliant on this assistant over time. One possibility I find kind of interesting about using AI as well is that we could try being even more fuzzy with intent. So what if, even double the quantities? That's sort of like a technical way to think about the problem already, right? There's a little bit of programmer brain. So what if, it's the morning, I haven't had my coffee yet, and I'm just like, I want a stronger coffee. Do it. And let's see what it can come up with. Okay, make the coffee a bit stronger. And it's just going to try to write a program that does that to this document, whatever that means. Okay, so what it did is it found just the coffee, and it multiplied the amount by 20%. Okay. Yeah, seems kind of sensible to me, right? And so I hope what this illustrates is, maybe we can get away with slightly fuzzier thinking and having more help turning our intent into precise goals. And again, if I thought 20% was the wrong ratio, I can change it. If the result didn't make sense at all, I can just delete this sheet and go on with my day. I have the ultimate say here. So far, I have a bit of a confession to make, which is that these are super cherry-picked examples. These are the cases that works well. It's really important to note that it often doesn't work well at all. That's just the nature of these systems. And at least, in my early explorations, I'm sure there's a lot more we could be doing. But we have to think about that case, right? I'll just show you one example of when it really didn't work. I was thinking, man, it'd be nice to just have a number at the beginning of each step in this recipe, right? So I say that, it churns for a bit, and let's see what it does. Oh God, what is that pattern? Some sort of cryptic regular expression thing. We have errors going on everywhere. I ask for an explanation, but the AI thinks the sheet does the right thing. So it just says, this sheet adds a number to the beginning of each line. And I'm like, no, it doesn't. I don't see the numbers, right? And so at this point, I'm kind of stuck. And so I think one direction to think about more is, what do you do when you get here? I will point out, at least we're not that much worse off than we were to begin with in the manual version, because at this point, I can just delete this useless autocomplete and try to do it myself. And that's where I would have been before anyway. So I'm actually, in these cases where we get a clear error, I think it's not a huge loss, but of course we need to think about how to make this experience better. Okay, now I just want to close by sharing a few tentative design principles that we've been toying with as we come up with this integration of AI into Potluck. One principle is code is actually kind of good. Code is really nice when it is capable of doing the task. Code is very fast. It does the same thing every time. You can look at it and see what it does. And so the principle here is, if code can do it, I claim that it's better for the code to do it than for an LLM to be doing it every time at runtime. The speed thing is very important, especially for reactive systems like this. I'm getting computations every keystroke. That you can't do that with a 5-second latency loop. These are very important qualities for something to feel like a tool that's predictable and not, an assistant that you're delegating work to. Another principle, software engineering still matters a lot. We can't just throw it all away. In fact, those ideas might even matter more now when we have these agents making code for us. So one thing going on here is modularity, right? We really want the auto-generated thing to be broken down into chunks to help me understand what's going on so I can zoom in on the parts I care about. Correctness and verifiability are huge. How do I know that this thing is doing what I thought it was supposed to do? We need techniques to sort of figure out if my intent is aligned with this auto-generated thing. There's one point that I think is kind of subtle, but one of the most important things going on in this demo. You'll notice I didn't have a ChatGPT window open to the side next to the Potluck thing, right? And the reason that I think that would be strictly worse is imagine the amount of copy pasting I have to do back and forth between those windows. I'd have to say, I'm using this thing called Potluck, here's how it works, I'm staring at this document about coffee, blah, blah, blah. What's happening in the demos I showed you is that all that's sort of taken care of for you. So when I type double the quantities there, we're not just sending double the quantities, of course. We're sending a whole tutorial that's been written on how to use Potluck, and also the entire document that you're currently looking at, which is extremely important context for interpreting your query, right? All that's being sent to the context to the model so it can do the best job possible interpreting your request and producing some response for you. We also saw with that query where I had to round it after the initial response, the demo is coolest when it works in the first try, and those are the demos that go viral. But honestly, I think those are the least interesting demos, because the reality is, for anything interesting, it's never going to be right in the first try. And so I think what we need to be thinking about is how can you design for that iterative loop and make it really easy to make one change to the thing that it did? What does that process look like? For anything complex, it's not going to be one shot. This is literally agile software development, right? We've really been through this whole thought process before as an industry, and we really need to not forget it. Finally, a few open questions and challenges that I'm thinking about in this space. First, how can we make that iterative loop better? You may notice when I asked the agent to edit the spreadsheet, the new result just suddenly appeared, and it didn't really show me what it did, right? Imagine if there was just a virtual mouse cursor where it could click on the parts that needed to be edited and it started typing in code, and I could watch it do it, just like watching my friend do it. Would that give me more ambient intuition for how these changes are being made? Maybe. Another question is intermediate representations. So far we've just gone straight from natural language to the final spreadsheet. But for complex things, sometimes it's nice to have a hop in between, right? Maybe a little back and forth of conversation or a spec doc, some pseudocode about what the plan's going to be, a sort of meeting point for AI and human to align on what the intent is before you go all the way to the final artifact. And I think designing these kinds of intermediate artifacts is going to be really important for driving better iterative loops. And the final one I'm calling reflection. And this is sort of a response to what I found to be the most frustrating things with doing this kind of automatic code generation in computational media, which is that it kind of feels like dealing with a really unreliable contractor who has no idea what they're doing and doesn't even lacks the ability to tell if they're going to get the job done. That's the worst part. Sometimes you feel like you're one step away from success, and you just keep going and going and going, and then 10 steps later, you realize, oh, okay, this is just not going to work, right? And I think the reason is that the model, we haven't done any work to have the model say at the beginning, oh, hey, that request isn't even going to work at all in this environment. You should just stop. And so I think, and beyond that, are we on track to get this task done at all? And so I think we need to think better about how to make these models reflective in the process so you get some guidance on whether this process is really going to work out. I want to close with just another bike metaphor comparison that I find evocative for thinking through these challenges, and maybe you'll find it helpful too. It's the bicycle for the mind versus the chauffeur for the mind. What do I mean by that? Well, when I think about a bicycle, it's a tool, right? It amplifies my natural abilities, and I have very, very fine control. So I'm biking to work. I can go fast. I can go slow. I can stop and smell the flowers. I can, turn. I'm enjoying the feeling of riding my bike. There's a lot of control over the process. A chauffeur feels more like an assistant to me. It's sort of an automation where I have a very abstract goal. I want to get to the Paradise Theater by noon, and somehow they're going to make that goal happen. And I don't care, what kind of car are you in? Do you have enough brake fluid? How fast are you driving? These aren't really relevant questions for me, as long as I achieve, the A to B, right? And again, as with earlier with the bike and the aircraft carrier, I'm really not saying either of these is better or worse. I Ubered here this morning. It was great. I didn't need to bike here. Sometimes you just want a chauffeur to take care of the details and do everything for you. But I think it's really important to think about when are those cases and when do you want a bike? When do you want a tool that you have more fine control over the process? And the hope with these computational media like Potluck is that in some cases we can give users finer control over their tasks and over the behavior they want in a way that feels really, really good and is not just sort of delegating everything to an automation, but is closer to this original vision where the human and the computer kind of have this symbiosis, and the computer really amplifies the natural abilities that the human has. All right, that's all I have time for today. Again, thanks to Max Schoening, Paul Shen, and Paul Sonnentag, my collaborators on Potluck. If you want to learn more about Potluck, this bottom URL here, incanSwitch.com/potluck, there's a whole essay we wrote about it, and also a live demo. So you can try all the demos I showed today on that website. To follow more recent updates and work, that's my website and Twitter. Thanks so much.
We'll take a couple questions. I see 40 questions. Okay.
Hi. How much of a blocker is the search aspect of it? Because regresses can be a little something,
Yeah, absolutely. So you'll notice we made a very intentional choice, which is that our search language is not just regular expressions. There's a few extra elements that we found were critical for making it more usable. The biggest one is that we have named sort of lower level searches that you can compose into higher level ones. One example is number. So you shouldn't have to think every time you want to search for a number, how do I find a number? That's a built-in primitive that you can then compose into larger, higher level things. And so I think that's really important. That being said, though, I will make one point, which is that there is a conspicuously missing thing from my AI bit here that I showed, which we haven't figured out yet, which is, as Rupert said earlier, actually AI is a really good fit for searching, right? Because it can find data in the text and pull it in and make it structured. And so I'd love to explore that more, especially for there are some searches that a regular expression just cannot do, like find all the ingredients in this recipe. We tried that. I downloaded a list of every food from the USDA, and it does not work well, I can tell you. And so I'm really excited to see how fuzzier techniques, like AI, can fit in there as well. Although there's, again, latency trade-offs and predictability trade-offs. And so that's some of how I think about search.
And can you guys keep your hands up so then we can easily see?
What's powering the explanation of how the AI generated the table, and a part two to that is what are your thoughts around building AI systems that show their work?
Yeah, absolutely. So the way the explanation currently works is it's a made-up post-hoc explanation. So you can take any sheet in the system, and all we do is we give the sheet to an AI and we say, hey, can you explain what this does? It's honestly not that complicated. The nice thing about that is that it can actually explain sheets that other people wrote, or even a sheet that you made and you forgot how it worked. So that's cool, I think. There's not really a strong guarantee that what it's saying corresponds to the behavior necessarily. And also, someone else here was pointing out earlier today, explanations are very contextual. Whether you know any JavaScript or whether you know about coffee maybe might affect the explanation that makes sense for you of what strengthening the coffee even means, right? And so I think this is really just the tip of the iceberg in terms of how good explanations could get. In terms of the second part of your question about showing their reasoning, I think it's a fascinating area. In this prototype, we explored having the AI do internal reasoning out loud, which has been shown to improve results. And we were thinking maybe you could even show that to the user. The problem is it slows it down. And already we're so bound by latency that having a fast iterative loop, even if it's worse results, seems to be better than taking longer to think really carefully within the AI about what to do.
This is actually more of a comment based off of a previous question. You were asking about searching semantics, essentially, right? Like the meanings of things. Have you looked at clip embeddings at all, or any of that kind of technology that might actually be incredibly useful to you?
Yeah, that's a great question. So I think for people who are less familiar with embeddings, I guess my basic understanding is that by taking the words in the text and putting them into a high-dimensional vector space, you can do more efficient search, very quickly in a semantic sense over maybe find ingredients we'll do a quick search and find all the ingredients. Yeah, so that's a great idea. We haven't tried it yet, but it makes total sense.
Potluck looks amazing. Last time you and I spoke, it was about a year ago, and you had just announced your riffle. And I guess I'm curious about where Potluck fits into the extended Geoffrey Litt cinematic universe, and what sorts of lessons you want to take from Potluck into some of your other PhD work, and what sorts of, I guess, collaboration has been going on between these two different worlds you operate within.
Oh man, yeah, that's a great curveball question. Let me think about that for a sec. So, okay, for people who don't know what Riffle is, it's a project that I've been working on. It's still active. And the basic idea is, why do we have this super complicated web stack? Can we just throw a relational database straight into your web browser, run it in the UI thread, and have your entire UI backed by a really, really fast, efficient relational database? Just write SQL queries in your React components, run it all locally. And there actually is a deep connection here that I think I don't often talk about, but the pitch that I make for Riffle when I try to explain it to normal software engineers is, oh, it's just a better way to make apps. You want to make an app, use Riffle. It'll be easier to make a fast app, whatever. But actually, I think I have kind of a deeper agenda that is actually closer to a lot of the stuff I think people here are interested in, and closer to Potluck, which is, it goes along the lines of what Mav was talking about too, where if you just get all the data into the client, that's a tremendous advantage in terms of being able to do what you want with the data, right? There's no API for accessing the data here. It's just all being slurped out of your tech stack. And so I guess the general thing I would say is there's a lot of potential for having local tables of data, and you can do whatever you want with them.
Hey, I guess I'm curious to learn more about the explorations you guys have done for your formula language. Is JavaScript something that was an intentional decision, or maybe is there a higher level representation that's easier for end users, or just generally curious about that.
Yeah, it was primarily a pragmatic choice. We just didn't have time, so we did JavaScript because it was the easy thing. We did add essentially a standard library that feels like spreadsheet formulas, so the round helper, and we just threw in 100 helpers basically, which helps make it feel friendlier. The interesting thing though is that now that we're doing automatic generation, I'm thinking, man, maybe JavaScript was the right choice, because I can just tell the LLM, hey, write a little snippet of JavaScript here. I don't have to teach it a whole new language with its own semantics. And so I'm kind of wondering if maybe it was accidentally a good choice.
Thanks.
Hey, whoa. That was amazing. It's so exciting to see your work progress. I have a question for you, but also for everyone basically doing LLM work, and this is my first thought whenever I see an amazing system like this, which is, what are your thoughts for making this work for anything except English? Is there a plan, a trajectory, or what does that look like?
Yeah, that's a great question. I honestly don't have deep thoughts on LLMs for programming across multiple languages. I've used LLMs personally in English, across English and Japanese, and I found actually really good success. I haven't used it for programming, but I found really good success in subtle translations and helping me understand details of language. I was actually just using it this morning. And so given that very limited experience, my optimistic hope would be that I could type in natural language intent in any human natural language and get it translated into code, get explanations of code in any natural language. Whether that optimistic hope is actually real, I have no idea. But yeah, it doesn't seem impossible to achieve, I guess.
Hi. I love the metaphor that you had of the bike versus the aircraft carrier, and this personal kind of activity versus a more industrial provided to you. One of the things I'm curious about is, I think many of my favorite pieces of software kind of encode a process that some expert has already thought deeply about. An easy example is, say, Things for iOS. It kind of encodes this process of getting things done, and it kind of shapes my action. I'm curious how you think about that kind of sharing existing expertise or schemas in this kind of world where everyone can create their own documents and schemas on the fly.
Yeah, thanks. That's a great question. It's a super important point. I really believe most people don't want to start from scratch ever. It's kind of, it's almost like why would you bother to start from scratch? The real use case to optimize for is start using someone else's thing. And then once you hit a wall and you get frustrated, there's that one tweak you want to make. That's the moment that matters, when you can open up the hood, dig around, see familiar stuff, and tweak. And so I think a vision for how you use a system like Potluck is, it comes with, it already comes with a bunch of searches built in. Like you saw, I pulled in a timer. And there's a bunch of stuff like that. There's a bunch of templates for using it for a bunch of different use cases. And you just start there. You just use those. You're essentially relating to it the way you do to any app that you download from the App Store. The only difference is that once you peek under the hood, you start seeing more familiar stuff. If you're interested in that idea, there's a beautiful paper by Alan Kay from 1984, which is the source of that quote at the beginning about editing our tools the way we edit documents. And the context for that paper is he says, what if you could make a word processor with a spreadsheet and a paint app? And it's sort of a wild idea. But the important thing is the point isn't that everyone's going to go say, I want to make my own word processor and hack away at Excel all night. The goal is just that as you're using your word processor, when something bothers you, when you open it up, you want to see familiar tools. You don't want to see a million lines of C++, right? And so I think that's an ethos that matters in this space.
Hey. So I always love the callbacks to spreadsheets because they're a beautiful interaction model and people have done amazing things with them and built maybe terrible things with them, but they're great. So kind of a silly question, but honestly, is there an Excel formula that when you look at from an interaction perspective kind of inspires your work? Like this one is really cool and I want to replicate that in my work.
Like my favorite Excel formula? Huh. Yeah, I don't know. I mean, okay, maybe like a cheeky answer would be like sum of numbers. And what the reason for that answer is, in a lot of programming languages don't have sum built in. You actually have to build it yourself, right? So it's like, it's not sum. It's like reduce 0, blah, blah, blah. And it's really beautiful because it's just these same primitives we're composing ourselves. And what's beautiful about Excel is that it rejects that and says, no. You're an accountant. You don't want to think about reduce. You want to think about sums. And it sort of is closer to the domain that the tool is mainly intended for. And so, like Potluck should have cooking formulas built in, right? Like you shouldn't be reinventing that stuff from scratch. I think Excel's really nice in that way.
So this talk gave me a random thought. Could you start with ingredients that you have in your garden, your cupboard, your cooler, and then have it help you design an exercise regimen to burn it all off?
Oh man.
We'll see you next year for that presentation.
Yeah, exactly. Great idea. I don't know, but I think it points to an interesting possibility, which is, I think a lot of people like to have little inventories of, like what's growing in the garden. And again, I think like a little note on your computer is a really nice place to just park that information. And my hope for a tool like Potluck is you have a natural place where the information kind of wants to live, and then you can augment that place with a little bit of computation. I'm sure there are like gardening apps, but or pantry management apps, but I don't need to download them. I just have the data in an authentic place that it naturally wants to be.
Hi. So I guess my question is more prosaic, but is Potluck open source? Are there plans for open sourcing it? Or?
Yeah, so I'm pretty sure Potluck is open source. I'm like 90% sure of that. If it's not, we should. You can get links to the code and the demo on the URL right behind me. That being said, we're not trying to turn it into a product necessarily. This is meant to illustrate the possibility of a tool like this, not be a standalone product. And part of that's actually for principled reasons, because almost the point of Potluck is this thing shouldn't be like a separate app on your computer. This capability, this loop of searching and computing and annotating should just be woven in throughout your entire computing experience. And so the broader project we're involved in at Ink & Switch is trying to bring ideas like this into a larger computational environment that we've, is a larger span of work. But yeah, absolutely. Go check out the code if you want to.
Last question here.
Hey, Geoffrey, thanks for the research. I'm Genya from DXOS, where we think that most knowledge scenarios deserve to be real-time collaborative with everyone in the community. Curious, I'm sure you might agree, curious your thoughts on that, but have you thought about that with Potluck? And like, if you're adding the AI loop, how would real-time collab kind of affect the UX paradigm, and what are the implications?
Yeah, great question. This thing obviously should be real-time collaborative. For scoping reasons, it's not. It actually is a web app that saves to your local file system, and then we like share files via Git, which is kind of interesting. It has its own charm, but I think it would be better if it was real-time collaborative. You know, I don't know how much it would change the interaction here, other than to say a very, very, very important thing in a tool like this is that you're not just sharing the docs, you're also sharing the tools that you're using to annotate the docs, and that should be happening live. So if we're in a meeting and I say, oh, it'd be really nice to, you know, if the timer tool worked this other way where you could have consecutive timers that chain on each other, and if that's something I can code up in 10 seconds, it should happen live on the meeting. I shouldn't have to ask you to like download a software update or something, right? The computations should live in the data substrate together with the data. That's a really important quality, which is shared by spreadsheets, you know, by Airtable, systems like that.
Thank you, Geoffrey.
Thanks.
Awesome talk.